Welcome to Tennessee's at-home learning series for math. Today's lesson is for all our sixth graders out there, though all children are welcome to tune in. This lesson is the 15th in our series. My name is Reggie Caruth, and I'm an assistant principal here in Tennessee Schools, and I'm so excited to be your teacher for today's lesson. Welcome to my virtual classroom. So if you didn't see any of our previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson, though it may be more fun to go back and see previous lessons since we will be talking about things previously learned today. So today we'll be learning about using unit rates to solve problems involving constant speed and unit price in mathematics. Ooh, that's a lot, right? Before we get started, to participate fully in our lesson today, you'll need the following: paper and a pencil and a surface to write on. Also, you really need a calculator. So if you don't have one, grab your phone and use the calculator on it. Y'all ready? Let's begin. Okay, so first, let's look at a constant speed problem. Be thinking about how we could use unit rate to help us solve it. So here's our problem. It says the jet flies at a constant speed. If the jet continues to fly at the same rate, how far could the jet fly in 85 minutes? Remember, constant speed means that the speed stays the same over time. What is an example of something that would not travel at a constant speed? One example that I thought about is someone riding a bike down a hill. The rate we are given in this problem is 170 miles in 7 minutes. Why is it difficult to find a rate equivalent to 175 miles in 7 minutes? You probably said that it's difficult to find an equivalent rate. 7 is not a factor of 85. So you cannot multiply the numerator and the denominator of the given rate by a whole number. What is another way we can solve this though? You're right, we can make a table to set up equivalent rates. Let's try a table. I'm gonna draw one, and I want you to draw one just like mine. You ready? So here's my table. So draw your table to look just like mine. So what I did was I started filling in what I knew, the rate that was given to us, 175 miles in 7 minutes. How can we find the unit rate in this problem? You're right, we can divide both 7 and 175 by the given rate of 7 to give us that 1 minute. So I'm going to divide this by 7 to give me 1 minute, which is what I need for my unit rate. And I'm going to divide this by 7 to give me what? Correct, 25. So now this tells me that the constant speed from this was 25, or my unit rate is 25 miles per 1 minute. It is helpful to start the table with the unit rate so we can find equivalent rates for any other number. So let's keep building on our table. How can I find how many miles in 85 minutes? Correct, I can multiply all of this by 85, because 1 times 85 is going to give me my 85 minutes. And since I did it to this side of my table, I'm also going to do it to this side. So I'm going to multiply this side by 85. So 25 times 85 is going to give me what? 2,125 miles. So this lets me know in 85 minutes, the jet went 2,125 miles. We can solve this another way by writing a constant speed as a unit rate. So going back to my original problem, I did 175 miles, 7 minutes. So to get my unit rate, to get 1 minute, I can divide 7 by what to give me 1? Correct, by 7. So I'm going to divide my denominator by 7 and also divide my numerator by 7 to give me that 1 minute to 25 miles, just like we did with the other problem. So now I can take this information, this 25 miles in 1 minute, and multiply it by my 85 minutes, because I already have 1 minute. So now I want to know 85 minutes. So when I multiply my denominator by 85, I also multiply my numerator by 85. That's going to give me 85 minutes. 25 times 85 is going to give me 2,125 miles. So again, it shows that the airplane travels 2,125 miles in 85 minutes. Isn't it crazy that I got the same answer doing it both ways? Okay, so let's see how we can use unit rate to find your unit price. What do you think a unit price is? Let's discuss this. Since a unit rate compares a quantity to 1 unit of another quantity, the unit price is the same cost of 1 item. So let's look at another problem. Let's look at this problem. It says Grocery Giant is having a sale on Swiss cheese. You can buy 24 slices for $7.20. How much would it cost to buy 5 slices of cheese at that same rate? I want you to take a minute to think about how we can solve this problem. Let's try using a ratio table to solve this problem. So here's our ratio table. How can we find the unit rate, which is also the unit price? Right, we need to find the price of 1 piece of cheese. Since we want the price per slice of cheese, we need 1 in the slice column. How can we do this? To get 1 here, how can we do that? We can divide by 24. Because 24 divided by 24 is going to give me my 1. And since I did it to this term, I'm going to do the same thing to this term to get my unit price. I'm going to divide by 24. So when we divide $7.20 by 24, that's going to give me 30 cents for 1 slice. So the unit cost is 30 cents. This means that every piece of cheese is 30 cents. So now that we know that, how can we figure out how much it costs for 5 slices? Exactly, we can multiply the unit rate by 5. So I'm going to multiply by 5. 1 times 5 is going to give me my 5 slices, which is what I'm looking for. And I'm going to do the same thing to my other term. So I'm multiply by 5. And that's going to give me $1.50. So at this rate, it will cost $1.50 for 5 slices of cheese. Another way we can solve this is to find the unit rate. So I'm going to raise this up. I know $7.20 for 24 slices, which was given for my problem. To get my unit rate, I can divide 24 by 24, which is going to give me my 1, which is what I need to represent 1 slice. Then I can divide 720 by 24, which is going to give me my 30 cents. So we can use the unit rate to find out how many slices now, how much it would cost for 5 slices now that I have this information. So I'm going to take my unit rate or my unit price, and now since I'm looking for 5 slices, I can now multiply by 5. So I'm going to multiply both my numerator and my denominator by 5, which is going to give me 5 slices, which is what the problem wants. And then 30 cents times 5 is going to give me that $1.50 per slice. So now let's see how we can use equations to represent unit rates. We're going to look at another problem. So good job at this problem. Now let's look at another one. Here's our next problem. This problem says a ferry boat at a constant speed of 57.5 miles in 2.5 hours. How long will it take the ferry boat to travel 92 miles? So we know that it takes what? We know that it takes 2.5 hours to travel how long? How far? 57.5 miles. So how can we find out how many miles it'll take to travel in 1 hour? So how can I get this to be 1? Correct. I can divide my term by my 2.5. So 2.5 divided by 2.5 is going to give me 1, which represents that 1 hour. And whatever I do to my top term, I'm going to do to my bottom term. So I'm going to divide that by 2.5 as well. So 57.5 divided by 2.5 is going to give me 23. So this lets me know that the ferry boat travels 23 miles in 1 hour. That's the unit rate for the speed of the boat. How can we use the unit rate to determine how far the boat will travel if we know the time? That's it. We will multiply the unit rate times the amount of time, and that tells us the distance. This can be written as an equation to show how many miles it goes. So distance equals the unit rate times the time traveled, or distance equals rate times time. The equation shows the distance is the product of the rate and time. This is a formula you will see a lot in later grades. So let's try it. So I know from my problem that the ferry boat traveled 92 miles, which that will represent my what? My distance. So I'm going to substitute 92 miles for my distance. What else do I know in this problem? Correct. I know my rate. My rate is 23 over 1, or just 23. So I can substitute 23 for my rate times my time, because I'm looking for my time. So now we can solve this equation. How do you solve this equation? Do you remember? Exactly. I can divide both sides by 23. This gets my time by itself. 92 divided by 23 is going to give me what? 4. So 4 equals t, or I can write that as t equals 4, which t stands for my time. So our answer is 4. We need to make sure we include the units now, because remember, our units is important. So what does 4 stand for? My units is 4 hours. So this lets me know that the ferry boat takes 4 hours to travel 92 miles. Good job, y'all. Okay, we learned that we can use 3 different strategies: ratio tables, find the unit rate, and equations to solve constant speed and unit price problems. We've done a couple of problems together, and you're doing a great job. So let's transition to you trying some problems, and then we'll discuss them together. Y'all ready? You got this. Let's go. So let's take a look at this problem. It says an ant travels 6 centimeters in 1.5 seconds. How far did it travel in 9 seconds? Think about what we've done today. How can we solve this problem? You're right. We got a couple of options to choose from. Let's start with a ratio table, my favorite. So build your table on your paper as I write mine down. So I know I have my time, which is in seconds. And I have my distance, which is in centimeters. So I know from my problem, the ant traveled 1.5 seconds and 6 centimeters. So now how can I figure out my unit rate? Correct. I can divide both terms by 1.5. To give me my unit rate, which is going to give me my 1 second. So that's 1 second. 6 divided by 1.5 is going to give me 4. So now this lets me know that the ant traveled 4 centimeters in 1 second. Is this what the problem's asking though? No, the problem wants us to find out how far the ant traveled in 9 seconds. So what can I do now to fill this in? Yes, I can go ahead and start multiplying my unit rate by 2, then by 3, and so forth and so on. But since the problem is only asking for 9 seconds, I can multiply my unit rate by 9. So 1 times 9 is going to give me my 9 seconds, which I'm looking for. And since I did it to that term, I'm going to do it to this one. Multiply by 9. 9 times 4 is what? 36. So this lets me know that the ant traveled in 9 seconds, 36 centimeters. Good job. Another way we can do this is we can do this as an equivalent ratio. So let's scoot this over just a little bit. So based off of my problem again, I can do 6 centimeters per 1.5 seconds. Make sure you write those units. And so now I can divide down to get my unit rate. And I know I can divide both of these by 1.5 because I want 1 in seconds, which is going to give me my unit rate of 4 centimeters per 1 second. Good job. Let's keep going. So now we can see the unit rate is 4 centimeters per 1 second. Now to figure out how far the ant traveled, I can now multiply by 9 to get my 9 seconds here. And since I did it to my denominator, I'm also going to do it to my numerator to keep them equivalent, to get 36 centimeters per 9 seconds. Great work using ratios to solve. The last way we can do this is use constant speed with the equation that we just learned, that distance equals rate times time. So, knowing my equation, let's fill in everything that we know. What does our R stand for again? Correct. Our R stands for our rate or our unit rate. What is the unit rate in this problem? Correct. Our unit rate is 4 centimeters per 1 second. So I can write that rate as 4. So I'm going to substitute my R for 4. You might have said 6. Why can I not use 6? Exactly, because I want to know the unit rate. So 4 is our unit rate for our problem because that's how far the ant went per second. So now, what does our T stand for? You're right, our T stands for time. So what am I looking for now for our T? 9 seconds, correct. So now I can replace or substitute 9 in for T. And I'm looking for my total distance, so I'm solving for D. So 9 times 4 is going to give me 36. Bring down. So D equals 36, but 36 what? Seconds. Good job. Make sure you keep those units. So let's look at another problem. This says Gerard paid $13.80 for 5 tickets at the same game. At the same rate, how much would it cost for 3 tickets? I want you to take a minute and I want you to think about this problem. Now, I also want you to solve this problem. You can use any method that we talked about. So, how did you decide to solve this problem? You could have said you wanted to solve using a ratio table, or you could have said using equivalent ratios, or you could have did it by using an equation. You can try to solve this problem in any way you wanted to. Remember, you could have used a calculator. So let's check and see how you did. Remember, you can choose the method that makes the most sense to you. That's the great thing of having multiple ways of doing something. When I show you a couple different ways, I want you to pay attention to the different methods to see if you can figure out how to do it the way so you can try the new method the next problem. So I'm gonna start off with a ratio table. So what are the terms I need to make sure my table have? Correct. The number of tickets to price. How can we determine how much does one ticket cost? Correct. We divide both terms by 5. So let's divide by 5. By 5. So 5 divided by 5 is going to give us 1. So now $13.80 divided by 5 is going to give us $2.76 per ticket. Now we can multiply both terms by 2 and by 3. So multiply by 2 and by 3. 2 and by 3. So when I multiply my first term by 2, that's going to give me $5.52. When I multiply my unit rate by 3, that's going to give me $8.28. So now my table's filled out. Let's see what the problem was asking us to do. We wanted to know how much it costs for 3 tickets. So for 3 tickets, it costs $8.28. Good job. You might have solved it this way. Using $13.80 over 5 tickets. You probably divide it by 5 to give me 1 ticket for $2.76. And then you took this information and multiplied by 3 to give me $8.28 for 3 tickets. So the last method we use is an equation. What is an equation we could use to solve this situation? You might have said something similar to this one. So my equation I can use is the total cost equal the number of tickets times the price of 1 ticket. I'm going to let that represent C equals N times T, where C equals the total cost, N equals the number of tickets, and T equals the price of one ticket. You could have used different variables in this equation, and that's fine. But the important part is making sure you define what those variables are. So remember, we want to use the unit rate when we're solving an equation. So let's substitute in our information. So I know I'm looking for my cost. The number of tickets I'm looking for is 3. And my price per one ticket, or my unit rate, is $2.76. When I multiply those together, it gives me a cost of $8.28. It is really exciting that you can solve the same problem in multiple different ways. Just make sure you just remember that there are multiple ways to solving these. And you can also use a calculator if you need to. Woo! We made it. Today we reviewed ways to use unit rates to solve problems involving constant speed and unit price. I hope you're seeing some connections to problems you can solve around your house and at the store. You did a great job today, y'all. After the video, you'll have some problems to practice on your own. I'll show you those problems now, or you can find them on the Tennessee Department of Education's website at www.tn.gov/education. Good luck, and thank you for hanging with me today. Listen, I really enjoyed reviewing unit rates and how they help us solve problems involving constant speed and unit price. Thank you for inviting me to your home. I really enjoyed working with you today. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Goodbye.